Hello and welcome. In this video, we are going to learn about greedy best first search, which is a heuristic based search. Let's assume that you are in need of money and you have to go to the bank to withdraw some cash. But you're not familiar with the location. Also, you do not have any help to find the bank. What would you do? You keep wandering around the streets, going from one location to another trying to find the bank, and you're exhausted when you finally reach the bank. This kind of search is known as uninformed search, where you do not have any information about the search space. Some examples are depth first search and breadth first search. Now, let's assume you have a friend who's familiar with the locality and also knows the estimated time to reach the bank from each location. With this help, you'll be able to find the way to the bank easily. This search is known as informed or heuristic search, which uses a heuristic function to help the search. An example is the greedy best first search. Here, the estimated time to reach the goal is the heuristic function, which helps you to reach the bank easily. Greedy best first search picks the next best node using the heuristic. Here, the search is aided by an open list, a list of unvisited nodes, and a closed list, a list of visited nodes. This search uses a priority queue to choose the next lowest value from the open list. Here, we can clearly see how greedy best first search differs from breadth first search. It is much more faster and efficient. We can also see the worst case time complexity and space complexity of greedy best first search. Let us now consider a real-world example where you are in Canada and you want to travel to India. Hypothetically assuming these are the only countries with airports and these are the flight routes. To choose the best route to India, let's solve this problem by modeling it as a greedy best first search problem. We maintain a closed list and an open list. Initially, we add the start node to the open list. Since S is the only node, we expand it and add its successor nodes to the open list. Since S is visited, we add it to the closed list. Since C has the lowest f of n value, it is chosen next. C is expanded and L is added to the open list. Now, L is having the lowest f of n value. Hence, we expand L and add I and J to the open list. Now, B has the lowest f of n value, hence we expand B and add D and H to the open list. Now, D has the lowest f of n value, so we expand D and add F to the open list. Since F has the lowest value now, we expand F and we get G, which is added to the open list. Now, G has got the least f of n value, so we expand G and get E, which is our destination. This is the final tree, with the solution path highlighted in green. Taking the path we just found using the greedy best first search method, we are traveling from Canada to the nodes S, B, D, F, G, and E, so we finally reach our destination, India. Now let's look at the algorithm. Step 1. We place the start node in the open list. Step 2. If the open list is empty, we stop and return failure. Step 3. We remove the node with the lowest h of n value from the open list and place it in the closed list. Step 4. We expand this node and generate its successors. Step 5. We check the successors if it is the goal node or not. If any node is the goal node, return success, else proceed. Step 6. For each successor node, we check the function f of n. If it is not present in both the open list and closed list, we add it to the open list. Step 7. Return to step 2. Greedy best first search can be used in different applications, from robotics to game playing to route planning. So, when does greedy best first search fail? In some cases, we see that greedy best first search is quicker but not optimal. In other cases, it is not even complete. It can get stuck in loops.